Hello, Algebra 1. Welcome to back to school stuff. We had a wonderful week last week with the EOC, and I'm really proud of all of you and all of your efforts with that. And I just want to let you know that I'm really glad to be able to teach you guys today because we're going to jump back into notes. We're going to finish out a few more sections, and then we'll test. Depending on when the test falls, it'll probably be combined into the final. So I wouldn't stress about this particular chapter too much in terms of doing well on the test. I would just focus on making sure you understand the content. So jumping in, we are in section 9.4, factoring to solve quadratic equations. You should have the notes and the homework from the tray. And let's jump right in. So before we actually get into the learning about how to do what we're doing, we're learning about something that you will take with you to Algebra 2 as well. It says solving a quadratic equation by square roots works if b equals 0. Remember we did that with graphing with square roots, and square roots was nice, but the b part, and what do I mean by the b? Well, I mean the b part of the ax squared plus bx plus c. So that part worked if it was 0. And if you noticed that we had that, it was like 4x squared plus 49, or even just x squared plus 49. And then you're like, oh, the answers are 7 and negative 7. So that worked out great, and graphing worked out great, but what if b isn't 0? Well, we actually had this already. The b not equaling 0 was like our quadratics that we would factor. So jumping in, we're going to talk about the zero product property, and that's if two numbers multiplied together are 0, then one, the other, or both have to be 0. So if a times b equals 0, then either a equals 0 or b equals 0. We can use this idea to to solve factorable quadratics by setting them equal to 0. What do I mean? Well, if you think about this, this is number 1. This is like number 1 on your notes and your homework. I think problems 1, 2, and 3. It says, what are the solutions of this equation? Then it says 4t plus 1 in parentheses, and then t minus 2 out of close parentheses, and then it says equals 0. So what does this mean? Well, earlier I said, well, if a and b equals 0, then one or both of these equals 0. So to get the solutions of this, we actually set both parts of the parentheses equal to 0 and then solve. So the first one says 4t plus 1. That t just got connected with the 4. I hope that you know what it is. So 4t plus 1 equals 0. So we actually solve this equation for 0. We'll do the same with t minus 2. We set that equal to 0. And so then we solve. So solving is just like normal. This is a two-step equation. You minus 1 on both sides. Just like you know what to do. You know what to do. You've done this before. 4t equals negative 1, and you divide by 4 on both sides. And you get t equals negative 1/4. Make sure you put the negative sign in the right spot. So t equals negative 1/4, that's 1. And then you solve this one, add 2 on both sides. And you get t equals 2. So your solutions to this equation, notice I said solutions because we have two variables. By the way, if you multiplied this together, you'd get 4t squared. So your solutions to this are, and you always write the smaller one first and think mentally negative numbers are always smaller than positive numbers. So you have t equals negative 1/4, that's one solution, and t equals 2. So those are your two solutions to this equation. So that's the first example. The second example, I'll switch colors, that way we can get some variety here. Variety is the spice of life. And I have x plus 1 in parentheses times x minus 5, and that equals 0. Again, if I multiplied this out, multiplied, distributed, FOIL, whatever, I would get x squared, so that means that there has to be at most two solutions. So I set each of these equal to 0 and then solve. So we have x plus 1 equaling 0. And x minus 5 equaling 0. So we solve these just like we've solved before. So we subtract 1 on both sides. And we get x equals negative 1. And then this one we add 5 on both sides. And we get x equals positive 5. trying to use my mouse because my screen was having sensitivity issues, so I apologize if you're hearing the clicks and you're like, it's like EOC testing all over again, hearing the mouse clicks. I'm sorry, but my screen was not working well. I actually trashed the first video that I made because it wasn't up to par for you guys. So there's the solutions for that, x equals -1 and 5. What do I mean by solutions? Well, say, for instance, I plug this number back into either this x and this x. Remember, when we plug it in, we plug it into both. And if I plug it into, say, this x here, so this is just kind of showing you why it is a solution. So this is just simply for your understanding. So if I plug -1 back in, I'm going to have -1 plus 1 times -1 minus 5. And I'm proposing that this does equal 0. Does it? Well, let's find out. -1 plus 1 is 0. Oh, sweet. So that was 0. But what about -1 minus 5? Well, that's -6. But 0 times any number is 0. Yeah, good job. And so 0 equals 0. So this is a solution. So it does check. This does work. And that's one of the cool properties about this. Now, I said earlier you're going to use this in Algebra 2 and college algebra, and you are. You will see this again. Moving on to the next slide. So here's your got it. If you would please go ahead and pause the video now. I'll give you a second to work out as your table, and then we'll talk about it. So go ahead and pause the video. Thanks. All right, so let's jump in and solve these. It says, what are the solutions of 2x plus 3 and x minus 4 equaling 0? So hopefully you set them both equal to 0 and then solved. So we had 2x plus 3 equals 0 and x minus 4 equaling 0. So if I solve these, then I'm going to get x by itself, so we subtract 3 on both sides. And you get 2x equals -3. And then divide by 2. And you're left with a fraction, and it's okay to just leave it as a fraction. So x equals -3 halves. If you convert it to a decimal, it's fine. I didn't really state, in the problem which way I wanted to see it. But simplicity's sake, I say keep it simple. Keep it simple. To solve the other one, we're going to add 4 on both sides, and it's a one-step equation, so we are one and done. So we have x equals 4. Our final answer for this then is x equals -3 halves and x equals 4. So x equals -3 halves, comma 4, to show that there's two solutions. We are done with the first one. The second one says, what are solutions of 2y plus 1 times y plus 14? So let's try green. So same thing. It's 2y plus 1, set that equal to 0, and then y plus 14, and set that equal to 0, and then solve. So to solve, we would subtract 1 on both sides, and then we get 2y equals -1, divide by 2 on both sides, and we get y equals -1/2. And then minus 14 on both sides to solve the other one, and we are done. So you get y equals -14. This one's not in the correct order, reading from left to right, so when you write your final answer, also 1, remember it's y's, not x's. Why isn't it x? Get it? Why isn't it x? I'm here all day, folks. So I've got y equals -14 first because it's the smaller of the two numbers, and then y equals -1/2. Box your answer and you are done. So that's how you do the first few on your homework. Jumping in the next part of notes, we will get through the next set, and then we will work on the following set tomorrow. So it's solved by factoring. It says, what are the solutions of x squared plus 8x plus 15 equals 0? And this should look familiar because we've done this before. This is the x method. The big X, not just any x, the big ol' X. So the big X method. So a times c goes in the top. This is a nice one because a is 1. Woohoo! Less work. So a times c, well, 1 times 15 is 15, so 15 goes in the top. So I'm looking for products of 15 that add up to be 8. And luckily for us, there's two products of 15, 1 and 15, that does not add up to be 8. The other one does, 3 and 5. So if I factor out, and this is one where we don't have to actually split up the b term because we are done. So oops, I did not mean to put the square there. So we break this up and we have our two factors. We have x plus 3 in parentheses, and x plus 5. So we just unfactored, defactored, or factored, I guess I should say. We factored out that quadratic, and we got x plus 3 in parentheses times x plus 5 in parentheses equals 0. So now we can do our next step. So basically what I did is I just added an extra thing. I added an extra step. So you've already done this. You know how to do this. We just did it. So we set them both equal to 0 and then solve. So x plus 3 equals 0 and x plus 5 equals 0. So we're going to solve both of those. So I subtract 3 on both sides. And I get x equals -3. And then I subtract 5 on both sides. And I get x equals -5. And then I go ahead and write those together as my solution. So I have x equals -5, comma -3. Again, write the smaller one first. And that's because we read left to right, and smaller numbers are left to right in the number line. That's the reason why we do that, in case you were wondering. All right, jumping now to the got it. So if you would please go ahead and pause the video. I'll give you a second to try this. Give you a hint. It starts with the big X method, and we'll go from there. All right, so now that you've had a chance to work through this, let's go ahead and solve. Well, let's do purple. So, big X method. Pew, pew. There's no A term. Your A term is 1. I'm saying that in case you see an A term. Hint, what we're doing soon. So the C term's -14. So factors of -14, that up to be -5. Well, to get a negative number in my multiplication, I need one positive and one negative. And the two factors of 14, 1 and 14, are not going to give me -5. But 2 and 7 will. So you should have factored out m plus 2 in parentheses times m minus 7 in parentheses. Both of those, 2 and -7, add up together to give you -5. So we set that equal to 0. And then now we can set our two parts equal to 0. So I have m plus 2 equaling 0 and m minus 7 equaling 0. So I solve. I'm going to go ahead and subtract 2 from both sides. And I get m equals -2. And add 7 on both sides. And you get m equals +7. So your two answers are m equals -2 and +7. Box your answer and you are done. On your homework, I need to see enough work to showcase everything that I have here. I know you guys have been doing these for a while and you're experts at them and you can do them in your head. However, I need to see your work. I need to see your thinking because I can't see inside your head. That's probably a good thing. This right here is stuff that you've done before in terms of writing them in standard form, you know, get everything to one side and then factoring. This one is a little bit complicated, but you can try it. So after you finish with your homework, numbers 1 through 3, you can also do, I believe, 4 through 5 at this point. This is like 6 and 7. So if you want to try this, you're more than welcome to. If you want some help, I'll be more than happy to help you. Just ask me on Remind. But here's kind of where I'm expecting you to be at. You should be done with 1 through 5 on your homework today. And then you should make an honest attempt with number 3, and then we'll finish going over this tomorrow in class. We have block scheduling the next few days, so please be prepared for that. I'm really excited to see you. Sorry that I'm missing out on seeing you guys today, but it's for good reason, and ask me about it tomorrow. So I hope you guys have a wonderful day today. I will see you later. Bye.